on the video as well, because there's a lot of instructions for this going into this homework and after so it takes a bit of getting used to, but there's more help also. So let me show you that. Have you started 8.2 yet?
Not yet.
Not yet. Okay. So let me show you that first. Let me go to the, well, yeah, I can do that, I guess. I can make this a tab and do I'll show you that. Then I'll put it back. Let's see. Let's do this. I think I'm not in, oops. I'm not in the right. There we go. I want to show you this part first. So let me share my screen once I get to the Canvas site. So this is the Canvas site we all know and love. And in addition to the, let me get to the course that we're in. Let me go to that. I can show you the modules. In addition to the regular homework modules for this week, we have some additional documents that go with our hypothesis testing. What you'll see that she did was she gave you specific instructions regarding your hypothesis testing, and you have to follow this or you will lose points if you don't follow this format. There are examples that are uploaded as well of this, and I'll be going through that. So she tells you, you have to indicate what your parameter is for the problem, either the mean mu, the proportion p, the variance sigma squared, or the standard deviation. The claim sentence and change it to a mathematical equivalent. You list the given information, and then you start your 5 steps. You put the step numbers inside a box, and then she gives you the 5 steps down here. So if you haven't taken a copy of this or printed a copy of this page, I would suggest that you do so. You don't have to duplicate the flow charts, but you do have to use the content in the flow charts, and I will go over that. Because for those of you taking the class online, you don't have the benefit of her going through this with you. So I will make sure that I go over that. But there are 5 steps. She expects you to follow this. Also, as far as other things that you'll need, there's an example of hypothesis testing. This is an example of the way that your problem is supposed to look. And there's a freebie in here. This happens to be the first homework problem in 8.2. So if you download this, for those of you who are watching later, you have the solution to 8.2 as it should be worked out. Okay, so that's there for you, and I'm going to go over that. Also, in the next section of your downloads for this week, we have the critical values and the p-values for a z-test. We're going to be doing critical values in 8.2. We're going to be doing both in 8.3 and on. So she gives you the directions for finding critical values with your calculator. Okay. and how many decimal places are necessary. For those of you who are using your calculator, you'll follow the top half of this where it says critical values, where they apply, and we'll talk about that. And the p-values, where they apply, we'll talk about that. For those of you who prefer to use the tables, she has the tables reproduced for you. And she has the instructions for how to use those tables. So they're there on a separate page. I just wanted to make you aware of that because a lot of students don't see that, and then they email us and say what's going on with the work. So that's what's going on with that. Okay. So as far as this hypothesis testing goes, we're going to pick up where we were from yesterday. Okay. But we're going to be putting together the steps. So I'm just going to go over that briefly, just for the sake of, okay. So we have the traditional method, or what we call the critical value method. That's these steps. That's what we're going to be focusing on. Okay. So we're going to be focusing on critical values for the Z here. And we're going to be putting our 5 steps together. This is your test statistic formula. Should look very familiar. This is the central limit theorem for the mean. This is the same formula that you saw there. So she gives you the definitions of all the variables. And here's when you get to, we're going to talk about this when we get there. When you get to step 5, where you write the outcome, you write one of these 4 exact statements, including the underlining. Okay. So you will write one of these 4 for every single problem, depending on what your claim is and whether or not you reject or do not reject the null. We'll talk about that, but keep that slide handy. That's slide number 5. Also keep slide 6 handy. This will be a bigger deal after 8.3. When we have 2 tests for the mean. Right now, we only have 1. So, so we're going to be stuck with the Z-test. But once you get through the chapter and you have to figure out which test to use, keep this slide handy as well, because you're going to be using it. Now, she goes through these examples in detail. Okay. And so you can see what her hypothesis testing actually looks like. We don't have to draw until we get to step number 4, but you should draw. You do not have to draw all of the multiples of the standard deviation. You just have to show where the critical values are. So you don't need to make an extensive drawing, but you do need to show where the critical values are so we can identify the critical regions. Okay. Those are there for you to go over. I'm going to spend some time in this video going over the actual problems that we are going to be doing. So here, let me bring up the, let me close this for a moment and let me bring up the homework. Let me maximize this. So the first thing we want to do in any hypothesis test, it sounds obvious, but read the problem and figure out exactly what they've given you. So it says the average depth of the Hudson Bay is 305 feet. Climatologists were interested in seeing if warming and ice melt were affecting the water level. 55 measurements over a period of randomly selected weeks yielded a sample mean of 306.2 feet. The population variance is known to be 3.6. Can it be concluded at the 5% level of significance that the average depth has increased? And is there evidence of what caused this to happen? So we have to know first what it is we're testing. So we're going to go directly to this. Can it be concluded that the average depth has increased? That's what I'm testing here. The average depth has increased. So if I was going to write that in a hypothesis, what do you think I would write?
Population variance is, sorry, the average depth has increased.
Average is what symbol?
Let me check.
That's a good idea. No, there's a lot of details. While you're doing that, I'm going to switch my screen share though, while you check on that. Because I'm going to get my download out here and see, did I not? Did I close it? Let me see. Oh, you know what I did? I opened a new screen. Okay, let me do this. What is the symbol for the mean? Do you remember?
Reach. Doesn't it say on the 8.2 notes?
It would say on that 8.2 note, but this is something you should know from before. What symbol were we using for the mean? Was it
Greater?
sigma square? It's greater, that's true. What is the letter that we use? The letter from the Greek alphabet?
A?
No, it's called mu,
Mu.
and it's the one that looks like the letter U.
Oh, the
Okay.
mean.
Right,
Yeah.
the mean. The average is always the mean. What I'm going to do is I'm going to bring up, this is the example. I'm going to put it on the screen. This is the example that I showed you a few minutes ago where the download was. This is the example. This is your freebie problem, okay? This will not be your only freebie problem, but I needed to get you started because there's a little bit of a trick here. And it doesn't mean to be tricky, but it's kind of a little bit of a curveball for the first problem you've ever done. So the average depth of Hudson Bay is 3.5 feet. So the first thing you're going to do, you don't have to write out the problem. I did just for clarity. You do have to write these first three things down here. So we're testing the population mean mu. So you do need to write parameter, population mean mu. You do need to write that. Okay. And you do need to write the 2 lines below that. Now, where did I get the claim from? Okay. If you look at the last sentence that I highlighted, can it be concluded at the 5% level that the average depth, that's our mean, has increased? Mu is our mean. Mu is greater because it's increased. Increased from what? Well, they thought that it was 305 feet. So that's where we get our 305 right here. And we're using what we call the traditional approach. Remember, I told you there were 3. We're going to focus on 2 of them, the traditional approach and the p-value. If she wants you to use the p-value approach, the problem will say that, okay? We're not going to be using it right away, but we do use both approaches. So this is a traditional approach. After that, before you actually start your hypothesis test, you read the problem and you pick out everything that's given to you. So mu obviously is 305 feet. Okay. It says 55 measurements over a period of randomly selected weeks. This is how many measurements they took. This is your sample size. And it's 55. Okay. Yielded a mean, a sample mean of 306.2 feet. Sample mean, we symbolize with X bar. X bar is 306.2. This is why, if you remember before, I've told you you have to distinguish the means, because this is mu is the population mean. Your sample mean was 306.2. The population variance, variance, remember, is sigma squared or S squared, depending on what you have. But this is the population variance. So we're dealing with sigma squared is 3.6. And alpha, which is our significance level, is 0.05. Any questions about any of this so far? Jason, are you with me? Jason?
Can you hear me?
Yeah, I can hear you. Now I
Okay.
can hear you. I don't know if your mic was just off, but I was still here. Do you have any questions about any of this so far?
No.
No? Okay. So now step one in our hypothesis test is to basically write our null and our alternative hypotheses. So this is building on the writing of the hypotheses that we did in 8.1, okay? So we know that we're testing mu is greater than 305 because that statement doesn't have an equal in it. It's not greater than or equal to, less than or equal to, or equal to, because it doesn't have that. That goes with the alternative hypothesis, and it's H1. So we put it with H1. H1 is mu is greater than 305, and that's my claim. So you want to be sure and write the word claim next to it, and then write the word right tail test. Now, it's the claim because the problem said so. Can it be concluded that the average depth has changed? That's the claim. The claim is that it has increased, it's changed, right? It's a right tail test because this is greater, it's pointing to the right. Now, the null hypothesis has to include the other two signs of direction. So this is greater, so it's going to go the other way, not greater, but less, and equal to. So the null hypothesis, H sub 0, is mu is less than or equal to 305. Now, there's a quirk in this textbook, and it's a lot of textbooks where even when your test is clearly right-tailed or left-tailed, it will always show the null hypothesis as mu equals 305. So this is what she's calling the statistical equivalent. If you have a statement that is left or right-tailed and you need the statistical equivalent is always equal. Okay. So the statement 1, and you need to make sure that you number your steps and that you box your answer, you box your step number, I should say. Okay, but step 1 looks like this. Now, because they didn't specify to us, we're going to use the critical approach, the critical value approach. As I said, you don't need to draw this, but you do have, she reproduces, for the clarity of your understanding, she reproduces the flow chart down here for you. You do not need to reproduce the flow chart, but you do need to ask these 2 questions. As I said, this will make more sense after 8.3 when you have more than just a mean to deal with. Right now, it seems a little heavy-handed, but she just wants you to get used to using the chart. So is our sigma known? Yes, it is. They gave it to us. Only they gave us the variance. They were tricky. They gave us the variance, but from the variance, we can get the standard deviation. So do I know sigma? Yes. That's an automatic use of the z-test, okay? But n is also greater than 30, which is also a yes response.
So I
So
put that.
on number 2, you write, first you write the answers to these questions. Is sigma known? Yes. Is n greater than or equal to 30? Yes. And then z-test. Okay. Now you're going to get your critical value. Okay. And you're going to, you can write inverse norm of 1 minus 0.05. And again, she reproduces, this is the calculator answer. So she's rounding it to 1.64. The calculator version is 1.6445, I think, something like that. If you're using the textbook or the tables, you'll get 1.65. For that value, that's the only value that does that. So if you're doing a mean and you have those, don't worry, she takes either one. Okay. This is part of step 2, by the way.
Okay, so but what does that have to do with 30?
Well, okay, so if the sample size were smaller, we would be using a t-test, which you'll learn about in 8.3. But our sample size is 55, so we're using a z-test.
Okay.
Okay, this chart will become more necessary after 8.2, but she wanted to introduce it now so that you have the benefit of looking at it, because a lot of students, when we get to the T's, don't know which one to use. This gets around that problem. Okay.
Mm-hmm.
You don't have to copy the flow chart. You just have to answer the 2 questions at the top.
Okay.
Okay. And then the next part of step 2 would be to write what your critical value is. Your critical value is the inverse norm of 1 minus 0.05, which is 1.64. Okay.
1 minus 1.64.
It's the inverse norm of 1 minus 0.05, and that gives us 1.64. Let me put it on the screen. Let me get my calculator out for you.
I'm looking for 3. I'm looking.
Oh, step 3, you mean?
Yeah. Yeah.
Okay, so step 3 is to calculate the test statistic. Okay, so the test statistic, this formula should look familiar, okay? This is x bar minus mu over sigma divided by the square root of n. Okay, so our x bar, if you remember, was 306.2 minus our mean, which is 305. Now here, this is why I wanted to take an opportunity to do this, because the formula here is sigma, notice. But they gave you sigma squared, remember? The variance was 3.6. So we have to take the square root of the variance here. That's a trick in this problem, okay? So you take the square root of 3.6 over the square root of 55. Okay. Normally, you don't need a square root at the top of that. Normally, you do not need a square root right here. But in this case, we do, because they gave us this 3.6 is sigma squared. Okay, so we needed an extra square root here to get our sigma. Okay. And if you work that out, your z value is going to round to 2 places. If you work that out, you should get 4.69.
Hold on. I think I calculated it wrong.
Let me put it up on the screen, because this is going to be I'll come back to this in a moment. Let me make sure that I'm sharing the screen. Here's my calculator. So we're going to go parenthesis. Did you get it? Or not? So we're
Yeah.
going to
No, I don't know.
Okay, so we're going to go parenthesis here. 306 point, what was it? 306.2? I don't remember what let me check that. It was, yeah, 306.2. Okay. So we're going to enter 306.2, which is our sample mean, minus 305, close parenthesis, divided by, we're going to open a parenthesis here. We're going to get the square root of 3.6, because that's our variance, divided by, make sure you're out of the radical, divided by the square root of 55. Make sure again you're out of the radical. Close the parenthesis. And then you're going to close the denominator, like so. Okay. And I get 4.69 as my z-score.
I got it now.
Okay. 4.69. 4.69 is your z-score. Now, what we have now is we have a way to go back and check our hypothesis. So if you remember from step 2, right here, the critical value was 1.64. So what this shows us, this is a drawing. If you don't have to make it as large as this, but if you make a drawing, you need to show us where your z-score is on the drawing. And obviously it's going to be to the right of 0 because positive. So 1.64 is my critical value. This is where my critical region starts. And my test statistic that we just got is all the way out here at 4.69, which is in this tiny, tiny portion of the tail way out here where this number is, okay? And so our test statistic definitely falls in the critical region, okay? So now for step 4, we're going to draw your curve, put in 1.64, shade the region, show me that 4.69 falls in that region. And then on step 4, you're going to write, step 4 is your decision statement. So we're going to write reject HO or do not reject HO. It's always the same statement. Reject HO or do not reject HO. And we're going to box reject HO because this should be rejected. And remember to box your step number. Okay.
Are you still there?
I'm here, Jason. You have a question?
Okay. No.
I know it's a lot. It'll get easier as you go, but it takes a lot to do this. So your quiz, by the way, only goes up to 8.3. So you have until Thursday to get through 8.3. So we have some time to work through some of this. Once you get through a few of these, it gets a little bit easier. Step 5 is your summary. Your claim, if you remember, was H1. Your claim is H1, and you're rejecting the null. So you're going to box, reject the null because you fell in the rejection region. Now, she reproduces. Remember, I said, keep slides 5 and 6 in your notes handy, okay? Because this slide is going to help you. So here, your claim was H1. So you're going to deal with one of these first 2 boxes at the top. Your claim is down here at the bottom. Your claim is H1 down here. You rejected the null. That puts you in this box where my spotlight is. And so your statement, your conclusion is going to be this statement. You don't have to add anything to it. You just copy it the way it is. There is enough evidence to support the claim. Now, remember, what were they claiming? They were claiming that the water level in Hudson Bay had increased. You don't have to write that, but I'm just trying to help you remember what the problem was about. So the statistical test did show that the water level had increased. There is enough evidence to support the claim. Okay. And if you remember, there was an additional question saying, why might this have happened? Why might the water level have increased? And I just put climate change may have caused the increase in water level. Okay. And that's it for question 1.
Okay.
Okay.
Mm-hmm.
That's it for question 1. Now, question 2 is about raw data. So we're going to need to put raw data in the calculator. I'm going to put it on the screen. Okay. So before we deal with the hypothesis test, let's put the raw data in the calculator, okay? So we all know how to put raw data in our calculator. I had done it prior to this video. So Jason, let me know when you're done and then we'll go over it, okay?
Okay.
I'm going to pull up the solutions to the let's see, here we go. Why is it not giving me?
Are you there?
Here,
Okay. I'm done with the data.
you're done with the data? Okay. Now I want you to go to, I'm going to put it on the screen. I'm going to go to my stat calc. I want to check one of my solutions because I had emailed her about this and I'm pretty sure I know why she did it this way, but I want to make sure that this is the reason, because 8.2 solutions. Okay, here's math 112. Let me see. Yeah, okay, this one is the one that, oh, this is the care one. I don't need the care one just yet. I need the, okay, this is,
Mhm.
genders 2.61. And then we're gonna deal with, here it is. She used 28.7. So we're gonna go with that. I want to show you where this is coming from before I put this on the screen. So here, we're going to look at that in a minute, but I want to, so this is our normal thing that we do, stats, and we go to edit, right? We enter our data, go to stat calc, go to one var stat, like we usually do.
Mhm.
Make sure you calculate it. Now, this could be a little bit of a time crunch. She told you which one to use, and she's using SX. I think the reason that she's using SX here, which is 28.7, is because technically this was sample data, okay? So don't worry too much about it. If you thought you were supposed to use 28.4 when you were doing this, go ahead and use what she's given you as 28.7. If she's given you the sigma, use that, okay? So you've got your you've got your sigma here, all right? Now, the next thing you want to do
28.7.
is that's your sigma. You're going to need that for your givens later. But remember, the first thing we're going to do is we're going to go ahead and write parameter equals mean equals mu, okay? Let's read the problem, though. It says a researcher estimates that the average revenue for the largest businesses in the United States is greater than $24 billion. A random sample of 50 companies is selected, and the revenues in billions of dollars are shown. At alpha equals 0.05, is there enough evidence to support the researcher's claim? Assume sigma is 28.7. So the claim here is H1, okay? H1 mu is, so when you write this, you're going to say, here the H1 is missing, but you'd write it as H1, and then you'd write mu is greater than 28.7. Okay, that's your claim. Now, then you write your givens. In this case, they came from the calculator, okay? Mu is 50, which we could have gotten from counting. We could have also gotten it from the statement of the problem. Sometimes the sample size, if it's raw data like this, will be given in the problem. Sometimes it isn't, but you can always get it from your calculator as well. X bar, that's the other number that we need from the sample, okay? We don't have it. So we're going to go to our calculator display, and you're going to pick up X bar, which is the top statement right here. I have 31.5. So if I put in the data correctly, let me see if I did. Is that what you have? Jason?
Hold on, I think I forgot to put in a number because I'm a number short.
Yeah, I have that problem. Let me see if I match hers or not. Okay, let's see. Yeah, I've got a different mean. Let me just see what the answer key says. Her answer key this time. Let me see what it says. Where is the homework?
Okay, I forgot a 22. That's the problem.
Okay, so I'm gonna pull up the,
Yeah, I got it right now.
okay. So now we have that. I'm gonna pull up the homework here if I can. Downloads, let me see. Pull up the homework here. All right, so we know what our, yeah, let me make sure that I match her data down here. "24, there is enough evidence to support the claim that," okay, she doesn't give it to you. She doesn't have it in the answer key, but she does have the H1 and the H1. Okay. So let me see. So what I have, let me check my data. What are you getting for the, give me a moment.
For
Let me
the
check.
X,
Yeah, what was your X bar?
31.5.
That's what I have as well. So for this, I'm gonna actually write this on the board because her other solution was missing it. All right, so here we have HO. Remember that our claim, let me go back to the beginning here. So we're gonna say greater than $24 billion, okay? The researcher claims that the average revenue is greater than 24 billion. So here, what we're gonna write, I'm gonna write this on the whiteboard here. So we're gonna say for number 2, we're gonna start with the preliminaries. We're gonna say parameter equals population mean meal, okay? Then you're gonna start with your givens. And we have, so we had mu was 24. Let me get the, so we had 24 billion. You can just write 24 and then the word billion. So here you have, and your 28.7 is your sigma. So you're gonna say that mu is 24. You're gonna say that n was 50. You had 50 numbers. You had an X bar of 31.5. This is X bar. And then this 31.5. And then your sigma, remember, was 28.7. So sigma was 28.7. Okay, those are your givens. Now we're going to go to the null and the alternative hypothesis. So this is your step 1. And remember, put it in a box. So step 1, we're gonna write HO, and the HO here is gonna be mu is greater than or equal to 24 billion. And H1 is going to be, and you also want to write, this is the traditional approach up here, traditional approach. And you're writing, this is the claim, which was, the claim was H1.
Oh,
And our
is
claim
this greater or equal to 24?
for HO, I believe, let me check the problem, because I think the problem says less than, doesn't it?
Because the
A researcher claims that, oh, it's greater. I'm sorry, I made an error there. It's greater than 20. Yeah, that was a good catch, Jason. Thank you. This is, your claim is greater. So let me just erase this part. My claim is greater. So that means that my claim is still H1, but it's actually going the other way. So this is going to be mu greater than 24.
for
Okay.
the HO.
Well, that's my claim. That's going to be H1. My HO is going to be less than equal to, because it's always the opposite of their opposite signs. So HO is going to be the one that's mu is less than equal to. This is less than equal to 24. My H1 is mu is greater than 24. This is my claim. And it's a right tail test. Just like the other one that we did. This is a right tail. Okay. Now we're going to go to step 2, which is we're going to calculate our critical value. Okay. But we have to ask ourselves the questions that we're supposed to. All right. So here we're going to say, we're going to find our critical values. So we're going to say, is sigma known? Is sigma known? Yes. Remember, if sigma is known, that's an automatic Z. So is sigma known? Yes. And is n greater than 30, which will make more sense to you why that's important later. Is n greater than or equal to 30? Yes, it is. Both of these, the fact that this first question is yes, makes it an automatic Z. So we're going to say use the z-test, okay? Now we're gonna find the critical values. We have one, the critical value is going to be, z is going to be the inverse norm of 1 minus alpha. 1 minus alpha, okay? And alpha comes from the problem itself. So if you go back to the problem here, it says at alpha is 0.05. Is there enough evidence to support the claim? Well, this is the same alpha that we had in the first one. So yeah, our z-score is going to be the inverse norm.
Is this one
of
for
that.
3? Is this step 3?
This is part of step 2 still, because we're finding the critical value. So this is part of step 2 still. We have a z-score in step 3, but that's when we actually plug in the values to the formula. So right now we're doing the inverse norm of 1 minus 0.05. Critical value z equals inverse norm of 1 minus 0.05. And this is going to be, again, it's 1.64, okay? Because it's the same as the last one that we had, okay? You do that with your calculator. Step 3 is where you plug in all of your givens from the top. So step 3 is this. We plug in our givens from the top here. And we get z equals, this is z equals X bar, remember, so X bar is 31.5 minus your mu, which is 24, over the standard deviation, which she gave you was 28.7, divided by the square root of the sample size, which was 50. So we're dividing by the square root of 50, okay? I'll put that in the calculator, tell you what I get. This is my z-score, okay? So I'm gonna go to my
Yes.
calculator here. And I'm gonna get my values, second quick. All right, so I have 31.5 minus 24 over the square root. Oh, no, not the square root, sorry. Over sigma, which is 28.7, divided by the square root of 50. So I'm gonna have, let me insert a parenthesis because I forgot that. And then I'm gonna have divided by the square root of 50. Second square root, 50 here. I'll move this out of the way. 50, and I'm gonna close it. And what I'm getting is 1.85.
I got that too.
Okay, so now we have a z-score of 1.85. Now we go to step 4. So let me write that down so that you can follow. Step 4 is going to be where we want a box. So here, oops, no. Use your imagination. So here we have reject HO or do not reject HO, right? Do not reject. We'll find out right now which one it is. So this is where we draw. So we're going to draw our distribution out. Doesn't have to be extensive. You just have to show your critical value and your test statistic. Your critical value was 1.64. So here's my critical value. I'm going to label it as my Z. This is my CV, okay? And it's going to be Z is equal to 1.64, okay? That's my critical value. Now, where is 1.85? Well, 1.85 falls in this critical region, right? So remember, another name for the critical region is the rejection region. So you fall in the rejection region here. Let's say this is where I'm going to draw it down here so that I can write appropriately here. This is my test statistic. This is Z equals 1.85. Now, since you fell in the critical region, you're going to reject the null hypothesis. So we're going to circle reject the null hypothesis there. And in step 5, we're going to go to our flow chart and we're going to write our statement that we have. So I'm going to pick up from
It's
the flow chart. Since we rejected the null, there is enough evidence and our claim was H1. So there is enough evidence. I'm going to show you that on the flow chart in a second, because that's the statement that you copy. So there is enough evidence to support the claim for number 2. Okay. So you would say that you would write, let me go here, go to step 5 here. Step 5, you box it and you say, there is enough evidence to support the claim. And you underline is, there is enough evidence, and you underline support. Whoops. You underline support. Okay. And that's a hypothesis test. Okay. Most of the rest of these questions are straightforward. Not all of them have the same alpha, okay? So be careful of that. But that's how hypothesis testing works. Okay, and that's an example of hypothesis testing. Okay.
Mm-hmm.
Okay, I'm running over a little bit, but let me see if I can. I'm gonna stop the recording here.